Okay, I was recording, then it got interrupted. Zoom got interrupted. So why are we, right? Okay, let me share my screen. Okay, this is in relation to stock price prediction using a paper like this. Okay, it is step 14, step 13, step 12, step 13 got stopped. That will be uploaded. So you can see, right? All of these things. So watch this, then you will know. So I think this is what we are doing, right? One of the simplest model, GCN MLP, and then this is the error. This is Pearson. This is spearman. Pearson related data. Now I will be bringing the uh, spearman related data. Okay, before that, let's Control C, Control B. Okay. Let's copy the data. So this is, I again paste for the other ones. Copy in one place, they take me in another place. Okay, the Pearson, and this will be the spearman data. Mean absolute error, mean absolute percentage error. Okay, mark it at spearman. And then Pearson. Okay, now I'll take the kendall tau. We already took the graph. So copy image and paste it. Okay. So I have some okay, let's try to reuse them. This is Pearson, right? So spearman and kendall. Not this one. This is kendall. And this is spearman. Okay, the slide probably need to make look a little better. For now, just keep it like this. Okay. Let's do the kendall related data, right? Okay, the same happened here. So mean squared error, mean absolute error, mean absolute percentage error, right? So take it there, and then Kendall tau, right? I think 2-digit after decimal should be good. Okay, now $45, $48, $27, right? Okay, ideally, you want to create some sort of plot. So okay, and that's what you get. The simple GCN with iteration 1000. So for this is probably doing better in this measurement. In this measurement is still it is doing better. Okay, probably this one did better here. Then this, same. This probably is the best, and then this, right? Anyway, this is the 0.6. Pearson 0.6, not the 0.51. Okay, in the meantime, I'm just writing some simple code so that I can bring this measurement data to data frame, so that if I need to plot them, I can plot them, right? I can plot them so that I can see the relative performance, right? So yeah, I'm browsing through the metrics, and then I'm creating list and then inserting at a particular place. I think this is sort of hard coded, but for simple thing, let's do it for now. So that's what I get for this DF matrix, right? Now we can plot it. Usually data frame will have options to plot it in different ways. We'll be trying to do some bar plot. Okay, a little bit of plotting. Let's say DF matrix plot. Okay, yeah, I just took the corresponding columns. I think I know there will be x-axis, y-axis, all those things will need to be there, right? For now, keep it like this. Okay, the plot looks the same because actually when I created this data frame for plot, at that moment all the executions are done. Actually, the last one, they actually represent the data for the Kendall tau. Okay, let's see. Epochs. Let's 10. so that I can generate this output and show that they probably will be a little bit different. Okay, when I defined it once, I really do not need for all of the methods. I can keep it the same, right? Okay, let's run it. I believe it will be fast. Okay, with 10 iterations, 10 epochs, we may not get much good result. Okay, you see it, right? But still, are they the same? No, they are not the same, right? Loss 50, 91, and 42. 50, 91, 42, the loss. Okay. The thing is MAPE, that is very large. So in comparison to this, for the Kendall tau, MSE is not that much. For Pearson, spearman, MSE is high, right? Okay, I'll run one more time, just 1000 times and see what happens and then stop this video. Save it. Okay, it will take long. Let's suggest pause it and then I'll come back. Okay, this is how it looks after I ran for 1000 iterations epochs. So TF matrix. Okay, so Pearson 50, 40, 27. So Kendall tau performs better in this sense. MSC, okay, still Kendall tau and mean absolute error, Kendall tau, mean absolute percentage error. Okay, in that case, spearman performed better, but Kendall toe is the second. Okay, I probably need to some sort of scaling or something else so that at least these down things they need to make bigger. Okay, let's copy this image. That's a better representation. Okay. Simplest neural network, GCN plus MLP performance. Okay, it is supposed to be as part of the graph plotting. I believe there is some ways you can pass these levels and then you can use it. Almost they aligned. Okay, we have something ready to show, right? Yeah, one got overlap, but I think not necessarily I need to keep it overlapping. I could move down as well. It's not a big deal. Okay, overall Kendall toe perform better as per the research paper. They all, in their case, Kendall toe actually perform better. So you can see GCN with Pearson, GCN with Spearman, GCN with Kendall toe, right? And GCN with news graph that I can also bring it here. The only thing is for the graph, I think financial news based graph. For that case, my data set will be a little bit different because I did not find the same stocks. I actually need to find out. I probably can try to match it, but in that case, it probably will be little, slightly little tougher. Data set. There will be some common for sure. So in that way, if I plot it, that can be a representative value, but in an absolute sense, that may not be actually absolutely reflective, but to some extent, it can be reflective. And yeah, that's all for now. Bye.